Hi guys, so today we are starting our trigonometry unit, which is exciting for some of you because there's no factoring in this unit. So we're going to start by reviewing some of the Math 2 concepts. So today we're going to talk about special right triangles, and before we get too far into it, I just want to show you some basic math rules that you may or may not remember from previous math. Back in the day when I was in high school, there used to be a rule that you could not leave a radical in the denominator. This rule no longer exists. However, on some standardized tests and even some online practice, your answer might not be there because they might have rationalized the denominator. So I'm going to show you what that means. So if you have a radical in the denominator, you can go ahead and fix that. So how do you do that? You're just going to multiply it by itself on top and bottom. So square root over 2 divided by the square root of 2 essentially is just 1. Remember, anything, so like 15 over 15, anything divided by itself is just 1. So the identity property of multiplication is 1. So you can multiply anything by a form of 1 like this and keep the value the same. So if I multiply this, I would get 5 times square root 2 is just 5 square root 2. Square root 2 times square root 2 is the square root of 4, or some of you might see that as the square root of 2 squared, and you might realize, well, these are inverses. Square and square root are inverses. They undo each other, so that's really just 2. If you didn't do it that way, then you see the square root of 4, which you all are so smart, and you know the square root of 4 is just 2. So this rationalized would be 5 square root 2 over 2. Let's look at just one more. So if I had 6 divided by the square root of 2, again, I want to rationalize this denominator, so I want to undo that square root of 2. So I'm going to just multiply it by square root of 2 over square root of 2, and I'm going to get 6 square root 2, outside number, inside number, those don't combine. Square root of 2 times square root of 2 is square root of 4. The square root of 4 is 2, so that comes out as a whole number 2. And then this one's slightly different because I have this 6 divided by 2 out here, and 6 divided by 2 is 3, so this is 3 square root 2. One other thing that I want to briefly remind you of is Pythagorean theorem. So hopefully you guys remember Pythagorean theorem, which is just a squared plus b squared equals c squared. So when you're doing this, A and B are the legs. It doesn't matter which legs because they're going to be added. Order and addition doesn't matter, but it does matter that C is your hypotenuse. And remember, your hypotenuse is always the biggest side, and it's always the side, if you find the right angle, it's the side opposite it. So if this is my right angle, this would be my hypotenuse. If this is my right angle, this would be my hypotenuse. So hopefully you remember that. All right, so let's dive in. The first type of triangle we're going to do, hopefully you either printed those notes or at least have them up as a file to reference as you're doing your practice for this worksheet. But the first type is a 45 degree, 90. So there should be degrees here because those are the degrees inside. This is also a right triangle. Anytime there's a 90 degree angle, there's a right triangle. And then since both of these are the same, this is isosceles. So we know this side is going to equal this side. And an isosceles right, the longest side is called the hypotenuse. That's in every right triangle. The longest side, which is the one opposite the right angle, is called the hypotenuse. And then these legs are identical, so I'm just going to call them both legs. Okay, so if I want to find x and y in this one, so this is 45 and this is 45, meaning these sides that are opposite those angles also have to have a congruent relationship, so they're both 5. So x is 5. And then I could use 5 squared plus 5 squared, a squared plus b squared equals c squared, or in this case, y squared. So 5 squared is 25, plus another 25 is 50. So 50 is y squared. And now I'm going to take the square root of that. We're going to break this down. Any two numbers that multiply to be 50. So I'm just going to use 5 and 10. 10 breaks down to be 2 and 5. Now I see this pair of 5s. Pairs come out as 1, so we kind of say those come out on a date. And this 2 doesn't have a pair, so it's lonely in the house. So this Y is 5 red 2. Your turn. So let's try again. So pause it and try it. All right, so let's try. So this is 45 degrees, that's 45 degrees, making this isosceles right. So these two sides are equal. So since this is 6, x is 6. And then I can say 6 squared plus 6 squared equals y squared. 36 plus 36 gives me 72. Take the square root. So I might want to use 8 and 9. Let me just give myself some more room. All right, 4 and 2, 3 and 3, 2 and 2. You might have broken it up differently, but you should get down to the same primes. And now I'm going to just look for my pairs. So I have a pair of 2. That comes out. A pair of 3s. That comes out. This 2 is going to be lonely inside the house. So now 2 times 3 gives me 6, and this is 6 rad 2. Well, that's interesting. This one, when the sides were 5, the hypotenuse was 5 rad 2. This one, when the hypotenuse is 6, my sides were 6 rad 2. So you might want to just look at that sheet that I had you download, and hopefully the rule makes sense. So anytime I have a leg, my hypotenuse is going to simply be the leg times the square root of 2. So now you don't even have to do all of that math if you want to remember the trick, or you can do the math because it really wasn't that hard. So that's the pattern hopefully you saw. So if they give you a leg to get to the hypotenuse, again, your hypotenuse is just equal your leg times the square root of 2. And I'm talking about 45, 45, 90 triangles. So don't go ahead and use that in any right triangle. It's only for an isosceles right. Okay, so we have our shortcut. Hopefully you have that written down. And now pause it, try it, and then come back and check it. All right, so this time we know isosceles right. These should have degrees. So x is the same as the other one, so that's 10. And y is hypotenuse, so it's leg times square root 2. I don't need to do the work because I remember the rule. Uh-oh, I think I added a page by accident. Okay, so now here's another one, and you do have the sheet with the rules, I understand, but you guys know that I'm huge on you understanding why the rules exist. So this one's a little different because now I'm starting with the hypotenuse. So if you want, you could say hypotenuse equals leg square root 2, and you could do the math here. So 10 is my hypotenuse, x square root 2. I can divide by the square root of 2 and get 10 divided by the square root of 2 equals x. And now I'm just going to rationalize my denominator. So if I want that square root 2 to come out, I'm going to multiply by rad 2 over rad 2. So I would get 10 square root 2. 2 times square root of 2 times square root of 2 is square root of 4, which is just 2. And then I have 10 divided by 2 gives me 5 square root 2. The other way algebraically, if I'm not using that list that I downloaded, is if this is x, I could also call this x because I know that this is an isosceles right and these are equal. So there's no point in having two different variables. And I could simply solve x squared plus x squared equals 10 squared. A squared plus b squared equals c squared. This would give me 2x squared equals 100. Divide by 2, and I'd get x squared is 50. Take the square root. All right, 2 and 25, 5 and 5. Yay, I see pairs here. This is 5 square root 2. So what's the relationship between 10 and 5 square root 2? When I'm looking from my hypotenuse to my leg is actually going to be the hypotenuse divided by 2 and then times the square root of 2. You don't have to remember that rule. Remember, you can just get there either using Pythagorean theorem, which is what we did over here, or using that one rule from before. All right, here is one for you to try. So please pause it, try it, and then come back. Okay, so Pythagorean theorem is something you should know hands down. So I'm going to just use Pythagorean theorem and use this as isosceles. Since these are both 45, their sides that are opposite them are also equal. So x squared plus x squared equals 6 squared. This is going to give me 2x squared. 1x squared plus 1x squared is 2x squared equals 36. Divide by 2. X squared is 18. Take the square root here. So maybe I want to use 6 and 3, 2 and 3. Here's a nice pair. So I'm going to get 3 square root 2. Or I could simply use my sheet and say, well, my leg is my hypotenuse divided by 2 times the square root of 2. So 6 divided by 2 times the square root of 2 would give me 3 square root 2. Either way is fine. All right, try one more. Okay, so this time I am just going to use the rule. So my leg is my hypotenuse divided by 2 times the square root of 2. 9 square root of 2 over 2. You might see it like that. It is fine if you wrote it like that. You will not see a decimal and then a square root. That won't happen. So please try to write it either as the fraction times the square root, or more commonly, you'll see them kind of slide this up, kind of putting that over 1. So this is probably the most common answer that you'll see for that. All right, halfway check. We're actually going to just skip that. I'm going to give you some at the end. We're going to move to our second type. So the second type is 30 degree, 60 degree, 90 degree. So here we go. We are going to start by investigating. So when you have a 30, 60, 90, you should realize the side opposite the right angle is always the hypotenuse. That's never going to change. So they needed to distinguish this leg from this leg. So the way they did that is the leg opposite the 60 degree angle, which is going to be the second biggest angle, they call the long leg. So the one opposite that 60 is the long leg because it's going to be longer since it's opposite the bigger angle. The one opposite the smallest angle is going to be your smallest side. So the smallest side, they're just calling the short leg. It is helpful if you always start by labeling. So where did the rules for 30, 60, 90 come from? So if I had a triangle that's a 60, 60, 60, this is called an equilateral. It's also called an equiangular. Equilateral, the lateral means that all the sides are equal. Equiangular means that all the angles are equal. They could also call this regular. So regular in a lot of our vocabulary we think is basic, but regular in math means that it has all the sides equal and all the angles equal. Can you think of the regular quadrilateral? In other words, what four-sided figure has all equal angles and all equal sides? A square. So, all right, so I know if this was equilateral, all my sides are equal, all my angles are equal. So we are going to start by labeling the sides any even number you want, or you can just wait and I'm going to pick a number for you in a second. So I pick 10. 10's an even number. So if I pick 10 and I drop this perpendicular bisector. Perpendicular makes this 90 degree angle. Bisector means that now I'm going to bisect these two sides. So essentially, I'm going to have a triangle here. Here's my right angle. I'm just taking this piece and moving it over for you. This side is 10. This side is 5. This was part of my 60 degree angle. Since I cut this 60 degree angle in half, that leaves me now with 30 degrees. So opposite my 30 degree angle is what I call my short leg. Opposite my 60 degree angle is my long leg, and the one opposite the right angle never changes. That's always your hypotenuse. So I have those sides. All right, so let's go ahead and find the altitude. So the altitude here, remember, would be what we just labeled our long leg. So we're just focused on this part. I'll draw it again for you. So there's 5, 10, and here's my x. So a squared plus b squared equals c squared. X squared plus 25 equals 100. subtract that 25. I'm going to need some more room down here. So we'd get x squared equals 75 square root. So let's move it way over here. Sorry, guys. Square root of 75, 3 and 25, 5 and 5. All right, here's my pairs. 5 coming out as 1. 3 is stuck in there. So I get 5 square root 3. All right, so what did you notice about the triangles we created? When we have your high 30, 60, 90, whatever this is, so remember it was 10, your short side is always going to be half of it. Because remember, that perpendicular bisector is going to bisect this side that's half this side. So I'm literally just cutting that equal angular in half. That is really, really important. If you know this first rule, you will not need the other ones because you know a squared plus b squared equals c squared. So what I want you to remember is your hypotenuse, right, is the side of any equilateral triangle. So if this equilateral triangle was 12, and then I came in here and I said, there's my perpendicular bisector, this side is now 6. So this is still the 60, 60, 60 here. So I want to make sure that this got split. This side is half of this. So that gives me 6 and 12. And then you can use Pythagorean theorem. The other leg, which we call the long leg, is whatever this is times the square root of 3. So when it was 45, 45, 90, we had a lot of square root 2s. 30, 60, 90, you're going to have square root 3. So if that helps you, you do have the sheet with all the rules. Please reference that as you're doing this. All right, let's find this example. So you might want to pause it, try it, and then come back. All right, here we go. So I'm going to start by labeling short leg, hypotenuse, long leg. Short leg's opposite 30, long leg's opposite 60, hypotenuse is always opposite that 90. So I can imagine in my head this being half of my beautiful, regular, equilateral, equiangular triangle here. So if this is half of that equal one, which, yeah, don't judge me, guys. I never can draw, you know this. If that was my nice equilateral, then this would be 3 because that came from a bisector. So this whole side would be 6 because all the sides in an equilateral are equal. So my hypotenuse, which in this case is y, is 6. I can use Pythagorean theorem if I want to find x, or I can use the rule and say x is short leg times the square root of 3. If you can't remember that rule, that is fine. You guys are awesome at math. That's why you're my rock star honors kids, and you can just simplify out this way. So 3 and 9, 3 and 3. Ooh, we cannot go on a triple date, so we only take 1, and that becomes 3 rad 3, proving the rule. All right, please try this one, pause it, and then come back. All right, once again, we have short leg. Here's my hypotenuse. Here's my long leg. So I'm going to use the rules for this one. I'm imagining my equilateral, which means my hypotenuse is just twice my short leg. So y is 8. My long leg is my short leg times the square root of 3. So 4 square root 3. Okay, let's try this one. Pause it. All right, hope you tried it first. Here's my hypotenuse. Across from the 30 is short leg, across from the 60 is long leg. So if this was my beautiful equilateral and I cut it in half, this piece would be half of 10. So y is half. In other words, the short leg is the hypotenuse divided by 2. Now I know this is 5, so my long leg, which is x, is 5 square root 3. You could use the Pythagorean theorem if you get stuck. Pause it, try it, come back. All right, I like the way yellow looks. So hypotenuse, short leg, long leg, and the triangle might flip. All right, so here you go. My equilateral's cut in half, y is 4. My long leg is my short leg times square root 3, 4 square root 3. We are flying through these examples. All right, here's another one. Let's do this together because it's a little bit different. Here I have my short leg. Here I have my long leg, and here's my hypotenuse. So you could use the rules, but I want to show you why the rules work. So remember, my hypotenuse is always twice this. So if this is y, I could call this 2y. So if I wanted to look at the math, and I know Pythagorean theorem is a squared plus b squared equals c squared, and c is 2y squared, that would give me 9 squared plus y squared equals 4y squared. Why I didn't make that an 81 there, don't know. So that should be 81. And now we're going to subtract the y squares over. I don't need to factor because I don't have a linear or plain y term. So I can just use square root property. 81 divided by 3. 3 goes into 8 twice. That's 6, so there's a remainder of 2. 3 goes into 21, 7. So y squared is going to be the square root of 27. So I'm going to take the square root of 27. 3, 9. We did this one earlier. There's a pair of 3's. So that would make y 3 square root 3. And then my hypotenuse is just twice that. So 6 square root 3. Please try this one before you unpause it. So pause. Okay, unpause. Long leg, short leg, hypotenuse. Let's use the rules here. So there is a rule that says your short leg is your long leg divided by 3 square root 3. Does that work in this last one where we actually did the math? So if I take 9 and I divide it by 3, I would get 3 times the square root of 3 is 3 rad 3. Yes, the rule works. So you can use the rule and do 12 square root divided by 3, square root 3. So my short leg here is 4 square root 3. Your hypotenuse is always just double that. So that's why. So x is 8 square root 3. Or you can call this 2y and that y, and you can use Pythagorean theorem. Okay, one more. Pause it, try it, and then unpause. Oh, the answer's there, so that was kind of silly. All right, so they wanted you to find QR. So this, in fact, is the short leg. QR is the hypotenuse. I wanted you guys to see this one because all the other ones had the diagram in the same order. So if this is my short leg and I want my hypotenuse, all I'm doing is doubling this. So 4 rad 3 over 3 times 2 is really like 2 times 1, so it's just going to be 8 square root 3 over 3. That's all. Sometimes they look scarier. All right, here's another one. Pause it, try it, and then come back. All right, let's label it. So this is short leg because it's opposite the 30. If this is 90, I'm left with 60. So this is my long leg here, and here's my hypotenuse. So my short leg is my long leg divided by 3 times the square root of 3. So 4 divided by 3, and then square root 3 times square root 3 is the square root of 9. And the square root of 9, let's just put that back. The square root of 9 is 3. So I'm going to have 4 times 3 over 3. These go away, and I just have 4. So my short leg here is going to be 4. Which, if we think about it, makes a whole lot of sense because remember, we also have a rule that the long leg is the short leg square root 3. So if I see that my long leg has the square root of 3, the short leg must be this part. It's kind of common sense. All right, hypotenuse is not hard to get to if you have the short leg because it's just that double. So that's 8. All right, so I want you to try these, and then I want you to come back. So try these 3, please. Pause it, come back, and here are the answers.